Hello, I'm Jonathan Charnes, and I'd like to explain to you what appears to have happened with the UPS flight 2976 accident in Louisville. I'm going to provide you with information that the NTSB is refusing to make public. Now, this information I've derived. I'm acting chief flight instructor of an FAA-approved Part 141 school. I'm also a flight engineer in a turbojet aircraft. I have first officer and flight engineer experience in the Boeing 727, a Boeing 737 airline transport pilot license, former FAA accident prevention counselor, former physics teacher. I provided the FAA and National Transportation Safety Board special investigators information that led to an airline shutdown in 1985. This video is for entertainment purposes only. Sources of information are Google Maps, Flight Radar 24, NTSB preliminary report on Flight 2976, ADSB data. The main calculations I've made have been confirmed by ChatGPT. You can also verify my calculations in an FAA-approved simulator level 4. You can basically get your license in one of these simulators without even getting in the airplane. They replicate what the plane does very accurately. All my conclusions are based upon data that was available. Some might be subject to change. Now, the NTSB preliminary report on UPS Flight 2976 fails to show if they could have landed. It fails to determine how the accident could have been prevented. In my opinion, they could have landed, and I'll go over this in this video, and also in a subsequent video, I'll go over the mathematics in more detail. But anyway, let's look at what I consider the contributing factors. One is the inadequate design to handle engine separation, which was approved by the FAA, because there's no automatic fuel shutoff. If you leave your nozzle at a gas station in your car and drive away, you'll pull out the hose and it automatically stops the gas flow. Well, when you pull a gas line out of an airplane and you don't have this automatic shutoff, you're going to have at least 8 pounds or 10 pounds per second gas spilling out, probably several times that. The 8 pounds per second is roughly what it burns, and the pumps have to supply more than that. There's also insufficient overrun that the FAA permitted and the Louisville Airport Authority and UPS. In my opinion, aircraft should not be operated at a weight which will prevent them from clearing all obstructions until they are at least 1,500 feet above the ground, following a double engine failure if they have 3 engines. The failure would be at rotation speed, or they should have the option to set the plane down in an empty field until they reach 1,500 feet above ground level. They should have a minimum rate of climb at 300 feet per minute on one engine, and takeoff configuration gear down. That's with a 3-engine plane, just operating on one engine. If they can't do that, then they need to take weight off the plane, make it lighter. There's a lot of airports that are a lot safer, like at Rockford, Illinois. The runway might be shorter, but there's a lot of fields beyond the end of the runway, and going to the south anyway. A lot of airports have a good place to overrun. Anyway, I believe the FAA fails to require pilot training with a dual engine failure. No operators that I know of provide such training. UPS pilots failed to raise their landing gear following engine separation and second engine failure. This probably could have prevented them from hitting an obstruction. They would have had a little bit better rate of climb if the gear was raised. Most likely, they failed to detect the second engine failure in a timely manner. Again, nobody trains for this, so you can't expect them to know what to do unless you train for this. They only train for one engine failure. One thing they should have noticed is that the plane's not climbing above 1,200 feet a minute. If you don't have that minimum rate of climb with two engines, well, you probably have another engine failure. And they probably had zero rate of climb or pretty close to that. So that should have triggered them to set the plane down. And I believe they could have done that. Anyway, let's look what the NTSB fails to provide in their preliminary report. The gross weight of the airplane. What did it weigh? The point on the runway where engine separated, and how high was it above the runway? The aircraft speed when the engine separated. Stopping distance from the point when the center engine loses its power. That's the second engine failure. This is where vertical speed approaches zero or rapidly drops. The air speed when vertical speed rapidly dropped. V1, that's takeoff decision speed. VR is rotation speed. And V2 is takeoff safety speed. This is something that is supposed to be provided on every flight. Before the plane's dispatched, they should get these in a printout. Okay, and what was the point on the runway when the plane had maximum altitude? Now, I probably can predict or calculate most of this information forensically, and that's what I'll be going over in this video and in the next one. Okay, I believe with adequate simulator training, they should have been able to almost immediately detect their second engine failure and land, or know if the plane was incapable of climbing with the gear down. By the way, if they raise the landing gear, they'll have a little bit more drag for about the 10 seconds it takes to raise the gear, because the landing gear doors open and add drag. So again, all this should be done in a simulator, an MD-11 simulator, to determine whether that's a good idea to raise the gear or not. When the plane's at gross weight, 630,000 pounds at rotation speed. Is that going to cause the plane to sink from this extra drag? Don't know exactly how much it is, but again, after 10 seconds, there's a lot less drag because the gear is up. Again, that should be tested in a simulator. Or in a regular airplane, fly it at a safe altitude and see what happens when you're flying near rotation speed, gross weight, and throttle back and just operate on one engine and see. Well, hopefully they'll try to do that. Anyway, yeah, they have an instantaneous vertical speed indicator. It tells you how many feet per minute you're climbing up or down, or if it's zero. And it's with two engines operating, it should be close to 1,300 feet per minute, maybe a bit more, possibly even up to 1,800 feet per minute if they're getting all their thrust from the other two engines. But if it's approaching zero, or a lot less than that, then they got serious problems. Okay, they also have what's called takeoff decision speed, which is V1. If you're above V1, then you're expected to continue to take off unless something really seriously happens. In this case, a dual engine failure. But there's two different values that the FAA defines for V1. Okay, And that's a point. One of the values is basically accelerating to the minimum speed you'd need on the runway and continue takeoff if you have an engine failure, one engine failure, and climb and clear obstructions by any required value. Now, that would be generally the lower value of V1. The other V1 is the fastest speed that you can accelerate to on the runway and basically stop on the runway within the remaining distance. And that's higher than the first one that I mentioned. And you can look this up on Wikipedia or the FAA websites. Generally, it appears that they use the lower value, the minimum speed it would take you to continue your takeoff and clear obstructions with one engine. Well, that's fine, except that if you're above that, you can most likely still stop. And I'm pretty sure that was the case with UPS 2976. What they calculated for V1 probably was the minimum speed that they need for takeoff following an engine failure, but with a long runway, they would be able to bring it down and stop, which I will show you now. And I'm going to go over points on the runway. One problem UPS 2976 did is they took off for an intersection. They didn't use the full length of the runway. It appears from the videos I've seen they took off from intersection B3, which is 846 feet before the runway starts. To use the full length, they would have appeared to have back taxied on the runway, turned around, and this would tie up the runway for a minute or two while they do that. Okay. Now, from the NTSB report, we know they hear a bell after 37 seconds. That's most likely the point where the engine separated. And they were at about 187 knots. I've also looked at Flight Radar 24 to get that 187 knots. And Flight Radar 24 says that they started the takeoff run at about 8 knots and accelerated to 187. However, they don't show 37 seconds. And I'll get into that later, but I'm going to use what the NTSB says, the 37 seconds since the takeoff started. And from this, I can just do basic physics and find that the distance to accelerate to 187 is an additional 6,013 feet. Now we need to know how many seconds it's going to take them to climb to about 50 feet. Because the NTSB said 50 feet was roughly the highest they got. And that would be equal to your change in height divided by rate of climb. On two engines, we can look at the thrust gradient and basically multiply the speed times the rate of climb on two engines minus the thrust required to maintain altitude and constant airspeed. Now, we know the thrust is about 60,000 pounds. That's the thrust one engine provides, because when they were down to one engine, they maintained their altitude, they maintained their airspeed for at least about 25 seconds. So that's pretty close to what it takes to maintain altitude and airspeed in that configuration. So the two engine thrust minus their one engine thrust would be about 60,000 pounds. And they were doing about 312 feet per second, which is 187 knots. We divide this net thrust, which is going to be used to climb, divided by the weight of the aircraft, and I get 30 feet per second. So the 50 feet height divided by 30 feet per second would be 5/3 of a second. Their speed, 187 knots, or 312 feet per second, times 5/3 of a second, going to be an additional 520 feet. Now, the reason I say this, because at maximum height, the 50 feet is most likely where the second engine failed. If it didn't fail, they'd still be able to climb. So very shortly after they rotated, second engine failed. Most likely the fire, all that fire burning, acted like one big fire extinguisher, because carbon dioxide is what's used to put out a fire, and that's what you get when you burn jet fuel, carbon dioxide and water. Okay, so now they have a dual engine failure, and they need to decide. Let's say it takes them 5 seconds with proper training to realize they aren't going to climb, or not very well. The distance is going to be speed times time, or 312 feet per second times 5 seconds. That's an additional 1560 feet. So now, if we add all these distances up, I get a total of 8,139 feet from the beginning of the runway that they can put it down and start to brake. See, the runway length is 11,887 feet, plus it's about a 400-foot overrun. And if I subtract this from what they've already used, they get 4,148 feet for hard surface braking. If I use a coefficient of friction of 0.4 because it's a dry surface, coefficients between 0.3 and 0.5 are generally used. I'm going to pick one in the middle. There's 10 out of 12 wheels with brakes. Acceleration of gravity is 32 feet per second squared. Multiply this out, and I'm going to get a deceleration of 10.7 feet per second, 10.7 feet per second squared. Okay, it's negative. Again, the distance I need to stop is 1/2 acceleration times squared plus initial velocity times time. I'm going through all that. I get a stopping distance of 4,725 feet. That's more than the 4148 that's available. In other words, I'm 577 feet short. However, there's a 700-foot grass between the end of the hard surface and the building that whose roof they hit. If I look also, let me figure out the speed at the end of the hard surface. Use this formula. They can be doing 92.6 feet per second. That's a little over 60 knots at the end of the hard surface. But remember, they got about 700 feet of grass to continue slowing down. And I'm going to use a lower acceleration because grass does not give you as much friction as concrete. There's many different coefficients of friction for grass depending upon what type of grass it is. This is not mentioned by the NTSB, but if it's a dry grass, I'll guess it's going to be about 0.7. I think that's a reasonable amount instead of what we get on the hard surface. And it'll take, here's our speed divided by acceleration, will be 13.2 seconds to stop it. That's 612 feet. So they have about 700 feet of grass, so that should work. Coming back, here's a little diagram I made, and as you can see, maybe I can center this a little better, but For some reason, they didn't use the full length of the runway. It appears that they started at B3, 613 feet to accelerate to 187 knots after 37 seconds. And then they continue about 520 feet, a little less than 2 seconds, where the second engine fails because that's their maximum height. And the airspeed staying the same. And if we give them 5 seconds to react, that's 1560 feet to put it back down on the runway. So now we've got, what is this? Let me think a second. Yeah, here we have 7,800 feet from the beginning of the runway, the hard surface ends, 700 feet of grass, and they should be able to stop. Oh, it looks like it's 56 knots they'd have at the end of the hard surface if they choose to stop. Unfortunately, they didn't, and at this point, after the first engine failed, that we had 25 seconds. During that 25 seconds, the plane traveled, oh boy, so its last point, hang on. Okay, I had to make a little correction. Here's the point where the first engine separates, and then here's the point where the data ends. That was 25 seconds, or a total of 7,800 feet, traveling at 312 feet per second. Here's the building, its roof they scraped. If we look from the beginning of the runway to the end, it's a total of 14,659 feet. And that seems to be pretty close to what Google Maps shows us, where, or rather the pictures from the NTSB, where the wreckage is. There's several points of impact on it, and so this seems pretty reasonable, because this would be about where one of those points of impact are. I don't mean the roof. They say that the wreckage stopped, I think, 3,000 feet from this building. This would be about 1,136 feet from it, which seems close to pictures where you see some burned out areas or damage. This distance, if you look at the 6 pictures the NTSB provides of the aircraft taking off, the second one shows the engine starting to come off. It's opposite a building, and it's opposite a hangar, pretty close to that. And if we look at that hangar over here, that most likely is this hangar. The plane's about here, and so I get about 6,542 feet from the beginning of the runway, which is pretty close to what I got here, 846 plus 613, maybe 6,800. So it kind of confirms my calculations. There's a lot of other information that is really questionable, and I can go over that in the second video, but we'll just look at some of it here.